Good evening, ladies and gentlemen. Welcome to the first CTL seminar. As you all know, CTL is a newly formed Center for Transportation and Logistics at IIM Ahmedabad. And we would really like to leverage the center resources to solve India-class problems in transportation and logistics. So today we know that India has many challenges in terms of coordination, and data is touted as a way to solve these complex problems. So today we are extremely delighted to have with us our first CTL seminar speaker, Professor Rob Zuidwijk. Professor Rob is a professor of global supply chains and ports at the Rotterdam School of Management in Erasmus University. From so far I recollect, he has always been a smart port professor. The chair position focuses on three topics, predominantly in the area of coordination for sustainable global supply chains, synchromodal transport networks, which is particularly important in ports because you have multiple types of modal interactions, both the ships, but also the trains and trucks. And you have to really ensure the synchromodality across different modal means. And his third position also looks into the inter-organizational systems in logistics. Professor Rob is widely published in his work is published in journals like California Management Review, Transportation Science, MSOM, Communication of ACM, POM. And he has participated and coordinated funded research projects in the area of international logistics and container transport. From what I recollect, I think he has many NWO funded projects, and several of them are long projects. So today we are extremely happy to have Professor Zuidwijk here. And without much delay, I think the entire floor is eager to listen to you, Rob. So the floor is yours. Thank you so much.
Thank you, Divya, for your kind introduction. It's my pleasure and honor to be presenting in this webinar of your center and to have such a distinguished audience. Feel free to share your camera, although obviously I understand for various reasons you may not be able to do so. But I would certainly like to invite you to engage with me in discussions. I'm quite sure that David will hold a close eye to the chat function for this purpose. And he knows that he can stop me at any time to take your questions. I have a considerable amount of slides and a considerable amount of material that I can cover. But the goal of this session is not to process those slides one by one and all of them. For me, the objective of this session would be to have an interaction with you, discuss with you based on these topics, and I'll be happy to take your questions and remarks. If all is well, you can see my screen with the first slide on it, which indicates the title of this contribution, this webinar, the role of data in container transportation. So maybe to go over a bit of the contents. So I will discuss with you the role of data in container transportation by discussing a little bit about container transportation, the role of information systems therein, and we'll look at some examples. So the projects in which I'm involved, which David already referred to, are both projects with industry, but also sometimes more theoretical projects inspired by industry. My examples will be combinations of both. We worked in many instances, we worked with industry to think about these topics, but sometimes we took the liberty to expand our research towards more theoretical developments. Some of them I also discuss, but put them in the context of practice, obviously. Synchromodal transportation, David already mentioned the word, but I will explain it to you as well to make sure that you are aware of what it apparently stands for. It has to do with a new certain way of organizing container transportation. And then I will go talk more about data sharing in transportation, covering a variety of topics that relate to this. And I'll go through them one by one. We can have discussions about it. I can skip one if needed, if time needs, but we can discuss that at length. And then I'll also go into some ongoing developments which relate to automated transportation and the role of data ownership. and then we'll conclude. So the key takeaways for today, beyond perhaps our discussions will bring about even more takeaways, but at least what I would like to try to cover is how single mode of transportation, which allows for more flexibility and efficiency in the container transportation system, is also data hungry. So we can try to use more advanced planning systems, but this comes at a cost as well. We'll see how that data for which you need to collect may indeed create value, both at the container but also at the cargo level. So one of the things that I would like to discuss with you is that when we talk about container transportation and to reap the value of data sharing in container chains, we may want to look at the cargo level. What's inside the box might be just as important as moving boxes around efficiently. As a result of these kind of considerations, we must realize that in the logistics industry, it's more and more defendable that being accountable for logistics performance is important. It will always remain important to justify any delays in logistics processing. We may want to hold, let's say, carriers and logistics service providers for being on time and delivering the goods in good shape, obviously. But what becomes more and more important is also to keep companies in the supply chain accountable for the quality of the data that they provide. So the story, as long as the goods arrive on time, it doesn't really matter what kind of data you have given to me, whether it was reliable, accurate, and so on. No, this will become different because we become more and more dependent on data as a source of revenues and cost savings. The quality of data will become more and more a KPI that we want to account for and may even penalize if you're not living up to the standards. In the general experience as a university, we see how innovative practices and academic discourse are very much going hand in hand, and some of the topics that I will discuss today might also relate to that. Okay, so as said, we'll start with the role of data in container transportation, and I'll build up that story by both considering some concepts, but also looking at some examples. So, yeah, I need to gauge a little bit your familiarity with container transportation. Maybe this is bringing water to the sea, as we say sometimes in Dutch. But let's take this short. You can please ask questions if you think things are not clear, but I'll assume that you have some basic knowledge and take it from there. So what we will be looking at is container transportation. Obviously, ports play an important role in that as a hub between maritime operations and land operations. Container terminals typically have the role of interfacing between the two. So we do see here that at sea transportation, at the left-hand side, we see large container vessels being handled by sea cranes. We have an intermediate stack of containers as a buffer to accommodate the transshipment of the containers at the land side, where they can be forwarded or received from and to hinterland destinations and origins. You could think about how much time does it actually take for the container to be moved between sea transportation and land transportation, which is referred to as dwell time. What is interesting, and I'll not discuss that in detail, but just to mention an important aspect of this whole system, is that dwell time can be seen as a performance indicator of the terminal. So actually, an efficient terminal should be able to reduce the amount of time it takes to bring the container from the sea side to the land side and vice versa. But actually, dwell time, it can also be recognized as a signal of the supply chain characteristics. So sometimes containers remain for a longer time at the sea terminal, not because the sea terminal is inefficient, but because the shipper involved, the owner of the goods, if you want, is actually not so much in a hurry. They like the free space, the free accommodated space to keep their goods in the port, so to see it as a storage place. This also articulates the connection between the port handling of containers, of steel boxes, which are in a way anonymous, and the story behind the supply chain at the cargo level. What cargo is in it? Is the container in a hurry or not? We'll refer to that later. Beyond what happens in the port, we will also today focus on what happens at the land side. This presentation, and I must admit my knowledge stretches predominantly at the land side, less at the maritime side. So we discuss also hinterland, what we call hinterland networks, where different modes of transportation can be used in combination, either in consecutive fashion, where modes of transportation hand over their cargo, moving from the port to intermediate positions and then forward, or as alternatives. I'll discuss that more in detail later on. In any case, the design of these inland networks is an important consideration. In fact, the example that is given here at the lower end of the slides from European Gateway Services is an excellent example of that, because it actually also indicates the business model shift by a seaport operator in the port of Rotterdam, as an example. I must admit that I'm a little bit biased towards this seaport. My apologies for that. You can probably understand knowing that RSM is at Rotterdam. But in any case, this seaport, so this is a port terminal operator, actually discovered that in order to operate that terminal better, they would need to take control of the inland transportation as well. And that's what they did, right? So I'll discuss a bit more about that later. But the idea is that basically they actually started to manage the container chain, the transportation chain, instead of just a hub in that container network. The way that information systems come into play, and as you can imagine, these consecutive steps in the container chain need to be coordinated, and that requires exchange of information, started off as what we might call collaborative systems. So the whole idea is that what we call interorganizational systems are systems that support companies to share their data. And this started off as what we call a collective action. So multiple companies are thinking, look, we will all benefit from the fact that we will share information. How are we going to organize that? Well, that sounds like a collaborative approach, right? And of course, you need to agree on the conditions under which data is shared and who is going to share that data, maybe a neutral third party that everybody trusts. But at least data sharing is seen as an enabler of operational excellence, and that justifies the role of a data sharing system. Now, port community systems are actually the exponent of that, right? So port community systems are in principle collaborative systems. So they're used by various organizations to help them to share data among themselves. Sometimes these collaborative systems have, let's say, first users that may actually entitle the right to use the system for free because they invested in it. Port community systems are usually operated by public organizations like port authorities and can be considered a public good. The port community systems help sharing data by providing information systems. And the question is a little bit, what is the value of such services, of these information services? This is the example of the port community systems of the Port of Rotterdam. They offer a variety of information services that can relate to import and export of cargo, transportation, but also the seaside handling of cargo vessels. And all of these services accommodate information sharing between different organizations. This all started with the accommodation of customs declarations for the cargo that was being transshipped, but this has extended also to particular logistics information services. And examples are, for example, the notification of containers that are to be transported by barge, and this may also support the planning of barge services in the port. So that's one type of information system, but what we have seen, and I assume that you're somewhat familiar with this, is that we also see digital platforms. Now, how can we maybe contrast them a bit with what we just saw before, is that platforms have a bit of a different business model. They're not necessarily seen as collaborative systems where a number of actors decide to organize their data sharing. They actually offer those information services. Those could be very similar information services as a value-adding service on the digital platforms, and the actors actually are users. Now, so those actors can either be producers and consumers of information services, right? So typically, if you think about how do actors in the container supply chain, for example, act as producers, well, they might deliver data. They might be the ones that let's say generate data in the port processes, and then they bring that to the platform. But they may also be consumer, right? They may also actually act as a consumer of those advanced information services. The interesting thing is that the platform economy and the platform business models very much are able to accommodate this. But this was also a discussion in the collaborative systems. There was a typical discussion of a port operator saying, look, I'm not very happy. I'm paying a fee to make use of this port community systems. And at the same time, I'm offering a lot of data to this platform. So how can I be compensated for that? And actually, to be honest, these collaborative systems we talked about a moment ago were not really prepared to deal with those kind of discussions. So data is an asset and not necessarily granted for free. It's not something that we are willing to freely share with everybody else. So instead of seeing this as in many reports, both in practice and in academia, it is advocated that people should share their data to allow for operational excellence. And this is all very well, but I think it makes more sense to be more aware of the fact that data is an asset that is not just granted for free, but maybe perhaps needs to be traded. If you have an excellent employee, you're not going to allow everybody to make use of that excellent employee just for the fun of it, or for the fact that it creates a lot of synergies. It's an asset. It's your asset, right? And you should accommodate. You should account for that. Now, there are a lot of different types of platforms already in the container logistics industry, maybe inspired by what we saw in the business to consumer world, like the Ubers and the booking.coms, or whatever platforms you are familiar with that you might actually use on a daily basis to order your products, to arrange your holiday destination, and so on. Also in the business-to-business environment, these platforms have emerged. But, and I think that is important, that maybe in contrast with the business-to-consumer world, the considerations I was just discussing in quite some detail are relevant here, right? So in the business-to-business environment, sharing data, consumers typically have a very naive approach towards sharing data. As long as the app that they use provides them with some value, they are willing to share a lot of data about themselves, even sometimes unknowingly, and not really knowing what's happening with that. In the business-to-business environment, I guess many of you will agree with that, are not willing to share data just like this, just of the benefit of having some value. You really would like to understand how much am I bringing to the table and how much do I get in return for that, right? Maybe to go a little bit more into detail about what kind of services are we talking about, and what is the exact discussions that we also encountered in the port and container logistics environment. Let's discuss a bit one of the typical coordination problems that we have seen in the port, and think about how that could be resolved using information services. So this is a particular example where we see how congestion may occur in the port because of the way that we organize our transportation. This is a schematic of inland barges, so river vessels, that visit the port to collect containers and to bring containers between the port and inland destinations and origins. And the idea is that, let's say, a barge, just a river vessel that starts at a certain city inland, brings containers that are destined to various port terminals in the port area. The port of Rotterdam, for example, is a big port with multiple terminals, but also to collect them. And so they make a round trip inside the port to do so. And the idea is that, well, you have time slots usually to berth your barge. You have to deal with certain issues. These seaport terminals grant priority to deep sea vessels. So there's a little bit of an uncertainty there whether a barge can be accommodated. This may result in a delay at one terminal, but if you have a round trip, this may actually result in a cascading of delays. Okay? So there are multiple options to deal with this. One option is to consolidate freight, for example, to make sure that the barge will only visit one terminal. This can be done by devising your logistics concept in a certain way, by hub and spoke system, or what they call an inland corridor, where an inland vessel will collect from various inland terminals containers which are destined to one single deep sea port. There are also other solutions which are now at the table where you actually try to decouple the visit of the barge to a terminal and the handling of the containers at the terminal. This is by having push barges. So let's say barges that, unmotorized barge compartments which are pushed by an engine that has containers on board that can be left in some kind of parking space near the container terminal. So then the push barge with the containers will wait for the container terminal to be ready to handle the containers, but the barge engine with maybe some other push barges can continue it for it. So you're decoupling the barge sailing from the handling of containers at a terminal. So that's another more technology solution, you could say, that is currently being investigated in the Port of Rotterdam. But another one is that you have some kind of collaborative information system which allows you to monitor and diagnose, let's say, these round trips, discover bottlenecks and solve them, and also do some kind of collaborative planning. And that's where a new system comes in, which is currently being implemented, which on the one hand collects data from all parties to do a good diagnostics on the system. At the other hand, also helps to plan, let's say, this barge rotation. The caveat that I see in this system is that they are thinking about a centralized planning. And actually, I think that's not necessarily a good idea. But that's a discussion which is on the table here. So this is an example of how information sharing and collaborative planning could come to an aid to solve a particular logistics problem in the port. So indeed, in this system that measures performance, does the diagnostics, and also comes up with some kind of dynamic planning, which is done in a central fashion. So one of the things that comes to play here is this idea about the value of data and the value of information services. And I already mentioned this example of how this could be contested, where certain parties bring to the table that they also add value to the system by providing data, for instance, but have to pay, but don't get rewarded for that, but have to pay for the information services that they consume. So they have this double role of producer and consumer of information service on the one hand, but do not get compensated for the producer role in such. Now, so we were studying this, and I will try to give a bit of an idea of how we were moving towards a solution direction for this problem. So have we look at this exact case of information exchange between barges and terminals to coordinate visits. Of course, you need to think about the information systems that accommodate that. And the value of these information systems, for the sake of argument, are operational savings. There could be other values, but let's stick to those for the moment. And in this particular study, we took those operational savings as a given. But anybody who has studied or has looked at, let's say, for example, vehicle routing or barge rotation type of problems might think about how to actually construct such savings. And if you can coordinate action in such a rotation of barges, you can imagine that the more parties actually adopt this service, and that's the graphics that you see here. So on the horizontal axis, you see the adoption rate, so the number of companies that actually participate in the information sharing. You can imagine that the savings per message grow. So if you're the only one who's using the collaborative system, your value basically is zero, because nothing really happens, right? You're bringing a lot of information to the system. You try to coordinate, but there's nobody to coordinate with. And the more people that start to act with you in sharing data, the more you're able to coordinate. But yeah, there might be an inflection point, some point where you will actually start to see a lot of benefit from it. And there will be also saturation. So the last few participants that also adopt the system may not bring so much to the table. In any case, you see what we can call the network effect, right? The more that participate, the more value you can gain from actually sharing data. And then we actually looked at that as a phenomenon in itself. So that was the basis for our study. We were not so much looking into how exactly does this network effect come into existence. This is also something you could look at, but we took it as a given. And then we started asking ourselves, okay, how do actors act as producer and consumers of information? We recognized also that some users may actually not like their data to be reused or used. We actually used a technique known as the Shapley value to determine how much does a data provider contribute to the value of the system, in order to start thinking about how can we compensate those contributors for their contributions. And what we discovered, and I don't want to go into all of the technical details, is but that network density between the players was one of the determinants of how much value actually can be shared and how data providers and data users benefit. For example, it might even be that in a high density network where a lot of data exchange takes place between producers and consumers of information, even competing producers might benefit from each other because they both add value to the same consumers. So this network effect that we studied in detail also about the structure of the network in which different players play a role. Another outcome was that given this network effect and the saturation, it's not necessarily true the more the merrier. It's not true that everybody should adopt the system. So one of the things that we also said is, look, you might not be able to drag everybody towards using the system, but that may not be a major issue. And this was also contrary to the intuition that if not everybody participates, we have a problem. No, that if you have a certain critical mass, that is enough. You don't need to have everybody on board. I also talked about reuse of data. And actually reuse of data is a very sensitive topic. Not only for business to business systems, also for business to consumer systems. I don't know about the exact discussions in India, but generally speaking, people don't like it if they share data with an app or an organization for a particular purpose, that information gets used again by another organization. There are very remarkable examples of that. We had a scandal, for example, in the Netherlands about a bank offering internet services to use the data from the consumers. They were planning, they were intending, they were like probing, what if the advertisements on a website are inspired by your bank account? You can imagine how much discussion that aroused. So reusing data for another purpose that it was intended for is in many cases a no-go area. Is that also true for in this context? And maybe yes, and in fact the emotion, let's say the initial response is we don't want a collaborative system or platform to use our data for other purposes than it's intended for. But what we started to study is, well, wait a second, but if we use this compensation scheme to allow reuse, but also compensate the original data provider for that reuse, maybe things change. So that's what this is just an example. Maybe to explain, this is on the lower right-hand corner, right? So we have this scheme where we have, so these are the ellipses, we have the different parties, we have the shipping agent, the terminal, and the barge operator. We have, and here we have some authorities. This is a Dutch name for our infrastructure management ministry, and this is customs, who are users of data because they actually are interested in the inland manifest, which is basically a declaration of the contents of the containers, or the containers actually which are on board of a vessel, inland vessel. Our ministry wants to know this because they need to manage the infrastructure, and customs wants to know that also, including the cargo data, because they need to, they actually, of course, need to approve the declarations and the fact that the container is put on the barge. So that creates value by itself. And these different parties on top provide the relevant data. So the shipping agent provides the cargo description, the terminal, the loading information, the barge operator, the loading list, and the inland manifest. And these are all components that need to be brought together to provide a barge planning and the cargo declaration for import, and in fact, in total, then the inland manifest. So we see here that, for example, the terminal is providing the data to allow for the barge planning. This is the immediate reason why they bring about their data. But they might also be confronted with reuse of the data. If you find a way to compensate the terminal, not only for the use of the data in their immediate information service, but also for consecutive information services where the data is reused, you have a proposition to make and let's see, ask for the possibility to reuse. Now for customers, maybe that is clear, but in other cases, we do see that this is not trivial. This could help us to accommodate reuse of data by compensating the original producer of that data. So this was done very much in the context of collaborative systems. Okay, so and there also it was important to notify that, yeah, you need to, if you have a collaborative arrangement by using a data sharing system, you must think about you must think about how to compensate the providers of data for their input. By the way, if there are any questions, please feel free to ask. So I'll move now to the next example, but maybe there are some questions so far.
So there are none of the questions right now. I think it was quite
okay. I would just continue.
Unless Avi, you have a question, Avi?
No, Prof, nothing. Yeah.
Okay.
Yeah.
We now move to from collaborative systems to platforms. And as I said, the way that I distinguish the two, and in some they have overlaps in terms of functionality possibly, but I try to differentiate it between them as a cooperative versus let's say, for example, a new entrant who just brings a business proposition to the market. So this is the case of platforms which actually try to use free capacity on barges. So I talked about this barge rotation example, and you can imagine that if a barge has a planned route in the port, and also given the dynamics, it is not necessarily clear at all times how much capacity that barge has available to bring, for example, a container from one port terminal to the other. So you have this rotation of barges. They represent capacity that might be available. They might have an empty slot, but this may actually be something that is a matter of hours, right? So at 2 o'clock in the afternoon, they have 5 slots available. In the morning, they even did not know about this because there was one container less to be picked up at this terminal unexpectedly. They have free capacity. It really requires a very dynamic system to trade free capacity on the spot market. Yeah? Now there is this booking.com of barge transport. I will not reveal the real name of the company, but they have this barge transportation solution where they say, look, we are able with our platform to work with this very small time window of opportunity to figure out what spots of capacity are available, and that we can find containers that need transportation to move from one terminal to the other, and then accommodate that by last minute reservations, bookings of it. Now, the information service that you need for that include reliable prognostics, because if you want to act fast, you need to know what's going to happen, basically. It's better to say, well, looking at everything that we know, using all the data that we have, we basically see it happening that a particular barge might have 5 spots available at 2 o'clock in the afternoon. So let's anticipate that. We, of course, need to check that, but let's try to, accommodate our demand that we see for barge transportation accordingly. Now the problem is, and that's for a new entrant, you're a new entrant, you are working with, you're trying to add value to a community which actually was very happy in just accommodating themselves. So you're like this aggressive new startup that tries to find a niche to work in. You create value because you're doing things that nobody else has been doing, namely accommodating the spot market at such a small time window. But still, you could be also seen as a threat. So the logistics community is not going to dump all their data into your system, right? So they're not going to freely share everything. So this might be a bit in contrast with the more collaborative systems, where although there is also the data sharing discussion, but there at least you have some kind of initial thought that we can help each other by sharing data, and let's do that, and let's try to organize that. And of course, there's also their confidentiality and issues, but still, a new entrant, that might be a completely different ballgame. So lack of data is almost like a given for such a platform. Now, the way that we were looking at this and trying to get our hands around it was with, actually I worked with an Italian PhD student who was visiting us, working with this startup. And we realized that we have a lot of sparse data. We have data based on the barge rotation, so we know where barges are. We have data on some orders, but we don't have complete data. So we basically have to, draw the puzzle ourselves. We have only some pieces, but we have also holes in the puzzle. We have an incomplete puzzle, and we need to figure out, try to draw a complete picture, and that's our prognostics. So we worked on that, and so we tried to understand container terminal productivity. So the figures below give you a bit of an understanding of how we are trying to understand, and maybe just as an illustration of how this worked. So these figures basically give a cloud of points that represent the relationship between the amount of containers handled and the amount of time it took to handle them, and let's say the nominal productivity of cranes. So at this left-hand picture, which was actually the planning data that we had, you can see that it actually doesn't make much sense to draw one line through these points, because that would be like trying to fit a cloud of data with a single linear relationship. But actually what we said, well, you can see if you draw two lines, then the fit is much better. And that actually represents whether you work with one crane or with two cranes. Okay, so that's how you're trying to understand what you're observing in the data from the idea that the crane has a certain productivity and that sometimes you use one crane and sometimes you use two cranes to handle a barge. Okay, so that was how we were going about, and this is by itself not a very advanced exercise, but it was part of let's say the exercise of looking at all sparse data and trying to build a complete picture around that. So we looked at both at the rationale of how are barges being rotated in the port, but also how productive are the different terminals, and that allowed us to come up with a reasonably reliable prognostics based on not too much data. So that gives you a bit of a picture of the kind of problems that you are facing and the kind of solutions that you can offer, and thinking about developing systems that use data that you get to devise value-adding services. And maybe the message is that if you have a collaborative system, you need to make sure that everybody's satisfied in being awarded the role that they take as a producer or consumer of data. If you are a new entrant that provides a value proposition to your customers, it's much more like a supplier-customer relationship. Then, of course, you may have to you try to get as much value out of your data as possible. Okay, I realize that we're taking much more time to discuss matters. There's always a lot to tell, so I might not be able to discuss everything, but still, I would just, I think I will take this next topic about transportation, Synchromodal transportation, to discuss that with you. Maybe we can do a small poll by raising hands. Who is aware of what the Synchromodal transportation is? I'm just going to want to briefly get a bit of a feel of whether people say, yes, we know this, or that, no, tell us, because I have no clue. Maybe you can raise your hand if you have some knowledge about Synchromodal transportation. Now I need to also look at participants to be able to see that. Like I'm going to. So please raise your blue hand. Maybe I need to, I'm not sure how familiar you are with Zoom. You should be able to make sure. David, can you help me? Is it that
they can use the reactions maybe? Yeah.
Oh, yeah.
That's blue hand. Some of them already raised the blue hand, so.
Okay, yeah, I see. Mohi has already raised his hand, her hand. Maybe others?
I would say suspect very few, maybe.
It sounds like it's maybe a good idea to explain what Synchromodality is. So sorry for that, Mohi and Nandini. So you're the ones that maybe you can help me explaining it. But it seems that the majority of people needs some explanation. I'll try to keep it, make it not too long. Okay, so I will not try to throw too many names, but it is useful though to explain the difference between intermodal, co-modal, and synchromodal transportation. Not so much to again to overburden you with all kinds of terminology, but much more to explain some principles behind it. So on this figure was actually a graphic that was used. It's inspired by a graphic for one of the port operators. So they actually were advocating these concepts to the market when they were developing it. So it's something that actually was devised by a port operator. So what we see here is intermodal transportation on top. So what happens here is that you make a planning to transport a container from the port, location A, to an inland destination, location C, via another inland location B, by first putting it on the train and then putting it on the truck. This is typical because not all destinations can be reached by the rail system. So it makes sense that if you use rail, use train, then also you at some point will start using a truck for the final mile. But you plan this in advance and you plan the consecutive use of different modes of transportation by intermodal transportation. The term intermodal transportation usually refers to the fact that you're handling the container, the loading unit, instead of the cargo itself, when you transship it from train to truck, for instance. Now, an alternative use of modes of transportation, and that was sometimes called co-modal transportation, is that you use them horizontally, as you could say. I think you're all aware of the fact that supply chain managers put the world upside down or tilted 90 degrees. There's a historical reason for that. But when we talk about vertical collaboration, we actually talk about in fact, about horizontal collaboration, because we usually depict the supply chain horizontally. And when we talk about horizontal collaboration, then we have a more vertical orientation. So sorry for that misunderstanding. That's caused by the way that we started to represent supply chains in a different way and did not really change the terminology. So horizontal collaboration here refers to the use of barge, truck, and train as alternatives. And so we may have planned in advance to use a barge to bring a certain container to a final destination. A barge is typically a slow mode of transportation. The container is late, so waiting for the next barge is going to take too much time. So we decide to have a fallback option to use a truck. Now then, of course, you're using the different modes of transportation, not as consecutive modes, but as alternatives. Now with synchromodal transportation, in short, you can say we have a dynamic approach. We allow for switching between modes dynamically. So we see the different mode of transportation both in a consecutive way. You may use different mode of transportation consecutively, but also as alternatives. So when the container arrives in the port, it needs to be brought to the final destination inland. You'll decide, based on the current situation, what mode of transportation to use. Now, I'll explain a bit. We all understand that there must be barges, trucks, and trains available, so you need to do some kind of capacity planning, but the allocation of containers to that capacity is dynamic. Okay, and if you take that as a given, you can still plan for that capacity, right? But it's not fixed. So that's also something that you need to think about, and key concepts here are when you book a container, you book it what we call amodal. So we do not articulate what mode of transportation is going to be used. We basically only articulate demand. So, and that's true, right? If you are a shipper and you want to move a container, you need mobility. You don't need a spot on a barge. You need mobility. You need to make sure that your container arrives on time at the final destination, or at least within a certain amount of time is brought to that destination. That's what you want. That's your demand. Not so much demand for capacity on barge X. You don't really care, right? You want your goods to be transported. So that's one aspect. The other one is that as soon as you do that, it allows you to deploy your resources as a carrier in a more dynamic fashion and opportunistically making sure that that you can use your capacity to the best possibility. You don't have empty slots that are not being fulfilled because containers are late, those kind of things. So you try to use your resources in the best possible way. Of course, you need to anticipate that. It may also mean that well, it actually means that you also start sharing your resources in a way that I explained earlier, that you have different modes of transportation, but also different departure times of the same transportation mode that you see as alternatives to accommodate a container demand for transportation. And this may also help you to improve the utilization of your resources and reliability of your transport service, because you have more resources available to accommodate them. Of course, it requires synchronization. So one thing that is important, especially when you have consecutive steps, you want to make sure that if you have a train and then a barge service connected, could be possible, that there's not a lot of waiting time occurring between those modes, right? So that's where synchronization comes in. Now we'll look at resource sharing and synchronization dependent on data sharing, and you can see how, yeah, that's natural. Right? So if you want to share your resources, you need to be able to understand what capacity is available, and if you synchronize, you also want to make sure that you know who is waiting for whom, when, and how can you accommodate shorter waiting times. So that requires coordination and thereby data sharing. I'll skip this slide. This is about some European developments around this concept, but I think that might be less interesting. I'm also looking at the time. I think we have about 8 to 10 minutes, right? 5 minutes. I'll take 5 minutes, so I'll think, yeah. So I'll give you one more example. I'm going to skip this one. I'm going to do, I think I'm going to do this one. This might be nice as an example of how we started to work with these kind of solutions and the value of data therein. This is about actually the consecutive use of transportation modes and how you can do planning. It's based on a paper that we wrote for transportation science, in which we had a stylized model about this planning, but it was based on actual working with companies around this topic. So the whole idea is, and I'll do this a bit hand waving. I'll try not to be too technical about it. There are no formulas here, rest assured. But of course, there is some mathematics behind it. Is that we are looking at the case where containers are available for further transportation, and that is uncertain. And the whole idea of this exercise was to say, well, we have a barge, and the obvious dilemma that you're facing is that if you have uncertain arrivals of containers, you can think about how often should you have a barge depart, when should the barge depart, and that creates some trade-offs. If you wait for a long time, you're able to have more containers on board because any late containers can still come along. It's like with if you have those small, I think you have in your cities, you have these small shuttle buses, right? And then if the shuttle bus waits longer, there are more people that can go inside, but then of course he departs later and you will arrive later. If it goes very early, maybe there are not too many passengers available. So you have to make a trade-off between these two. Right? So that's the basic idea here. But you have to meet the deadline in the end. So you need to think about these barge departures, and you need to think you have to think about that in advance and think about this lateness probability. How likely is it that many containers will be too late for that barge? And you need to think about the decision to put a container on a barge or a truck. If it turns out that the container cannot be put on a barge, you can make sure that you have a truck shipment available for that container. Now, so there is some data sharing between the container terminal and provider of transportation services inland, so that to accommodate, let's say, these deadlines with the planning at your terminal. And you can think of different information scenarios. So the synchromodality concept we just discussed actually requires a lot of information. And that's actually almost like the ideal situation. And in the study, we wanted to understand the value of information by looking at various information scenarios. One is no information. We're not sharing any data. One is that you have some kind of prognostics, like a stochastic distribution, as we call it, about the time that containers become available. We might have a more fine-grained, as a third option, more fine-grained understanding based on cargo information when containers are available and how much time pressure they have, you want. And we could have a situation where we have full information. So everybody's sharing a lot of data with each other and we have the ideal full information situation. Now what we did was we decided to express the value of information. There's a question by Pawan. I'm happy to take your question, Pawan. I see your. Or is it? No, it's VGR. I mean, I don't know. I don't know who's.
That is.
I don't know whose hand that is. It looks like it's VGR. I think Pawan is making a lot of noise.
Please continue, Prof.
Okay. I thought that somebody wanted to ask a question. So for each information scenario, you can think about what is a trade-off between efficiency and reliability. And there is this trade-off because if I put all the containers on this cheaper mode of transportation barge, I have two effects that will deteriorate my reliability. First of all, the barge is slower. And secondly, containers are waiting for the barge to leave. So I'm having two ways of how my reliability, the probability that I will arrive in time could be compromised. So that's how how we can see this trade-off happening. But the way that this trade-off actually comes into existence through what we call a Pareto frontier, an efficiency frontier, will be different. So let's look at this. The first information scenario actually is a point, because that's the point. We have no information at all. We don't know what to expect. What we're going to do, we're going to truck everything. We're just going to wait for a barge to arrive out of nowhere. We have no information, right? That's the situation that we're talking about. And we truck it. So that's very, well, reasonably reliable. It can still be late, because if the container is late. But in principle, that works okay, but it's not efficient. We use an efficiency scale between 0 and 1, where this efficiency 0 demarcates trucking everything ad hoc, and efficiency 1 basically demarcates, indicates everything is barged. Two extremes. Reliability is the percentage of containers between 0 and 1, the fraction of containers that arrive on time. Then in the second scenario, we have this efficiency frontier. There's a nice shape. It's not convex for those who are interested in mathematical details. So actually that makes it, you cannot actually use an approach where you scalarize your trade-off. So that's maybe an important thing. Here, what you do is you balance your container population in such a way that you designate them to barge and truck in a certain way, according to the statistics of the overall container population. You can gain something by doing this per category of containers. Now you have subpopulations of containers, and you do this balancing act for each specific category segment of containers. Could, for example, be based on product characteristics. And the fourth one is now we actually have full information. Now you can start thinking, okay, you know, which containers are going to be put on the barge? Those that arrive last minute as compared with the departure of the barge. Because I know these arrival times beforehand, I can really play around with this in a lot of detail, and I can really optimize the system completely. Now, what is interesting that at least for this numerical example, we see that the relative improvement of this efficiency curve, and please realize that being fully efficient and fully reliable in the top right corner is the ultimate thing to achieve, is not that spectacular. And so having yeah, no information really is something else. But if you talk about stochastic information, this distribution of arrival times, it's okay. If you then fine grain that a bit, you make a step. But if you go to full information, it's just a little bit more. So in fact, this what you can conclude from this is that even if you have only partial information, that already brings you a long way towards the ideal situation of being able to coordinate. So that was a nice takeaway from this study. That if you know how if you know which data to collect, you might actually make a lot of progress just collecting partial information as opposed to full information. I need to wrap up, and I will do so by putting up the key takeaways, but I'm happy to take any questions.
So Rob, there's one question on whether it is possible to incorporate autonomous tracking and AI to track potential real-time data by logistics.
Yeah, so certainly, yeah. So this is something that I was going to discuss if we would have had 2 hours.
We'll do part 2 of this, Rob. It's not done yet.
We do it part 2. So, so sorry for that. I took too much time explaining things. But so one of the things that we're looking at is for in automated transportation is track platooning, and we're also looking at other types of automated transportation. And yeah, one of the things that we're currently investigating is autonomous vehicles are notoriously collecting and generating data. So one of the things that comes about there is who's actually the owner of that data, and who's going to use that data to provide superior logistics services. And what is interesting is that because of the automation, that data ownership may shift to the automotive producer, to the automotive vehicle manufacturer, or the provider of mobility, if you want it. So, and I think that's a very interesting development. The same may be true for warehousing, by the way. It's looking at your field. Who's actually going to manage? Maybe the manufacturer of robots is going to be the one managing the warehouse at some point, because they actually are collecting the data, at least to get their hands on it. So this is a question that plays here as well. We had some very interesting discussions about autonomous cranes, and indeed there might even be you might even have competition within a terminal or a warehouse about different providers of automated systems that collect their own data, optimize their own operations within the warehouse. So all of a sudden, you don't anymore have a centralized system owned by the, let's say, the logistics service provider, but actually multiple systems that each operate their sub-processes based on the data collected by the producers of that. So, yeah, so that I think there are some interesting discussions around that.
Right. We take one last question, Rob, before we kind of close. So there was a question on how freight forwarders can play a role in the synchromodality, right? So there was. So do you have any take on that?
Yeah, so the typical discussion around synchromodality is, and to explain the roles, so you have the carriers, the logistics service providers, but you also have the freight forwarders that may usually capture a more comprehensive set of services in the supply chain context, and the shipper. There is a debate about who should ignite, who should initiate synchromodal services. On one hand, you can say that, well, logistics service providers, perhaps freight forwarders, are able to consolidate freight flows from different shippers, but also shippers, at least in the Netherlands, when looking at Synchromodal container services, have actually taken the initiative to consolidate their freight. And what they were saying is, look, we know when we want our goods to be shipped. So we should be in the steering. We should sit in. We should be in the driving seat here. So actually, that role to play has been contested in the supply chain. So either was it the carrier, logistics service provider, a freight forwarder, or the shipper / freight forwarder taking that role. freight forwarders could play that role, certainly, as they're close enough to the details of each individual supply chain and know how to consolidate freight from the standpoint. But it's contested. Yeah.
Right. There are a few other questions, Rod, but we'll keep that for part 2, right? So I think it was
okay. Yeah. So
to have you here. I think we all enjoyed all the different use cases, and I was telling you, it's pure fascinating to see how much importance it is to leverage data and how can collaboration play a larger role to bring economies in the whole supply chain. And that's something we definitely get from this whole presentation. But I'm sure it's not over yet. We'll have you here very soon again to continue the debate on data. Yeah.
Thank you very much, Debiet. And I hope I must say, of course, there was a lot of information provided via this channel. It's always not always that easy to have interaction through video. But if anybody of you has some further questions, I'm quite sure that they can be brought to me, and I'll be happy to respond to them.
Sure. Thank you again, Rob, for your time, and thank you all the participants who joined for this webinar. We will keep happening this kind of webinar once every month in a particular topic of transportation logistics. So do join us for the next webinar, which is planned in sometime in April. Yeah, thank you again.
Thank you very much.